Grandpa, what's wrong?
Mary Kate, it's almost my time. But my last wish is that you teach me about 4 concepts of physics. It's gonna be conservation of mechanical energy, momentum, impulse, and collision, conservation of momentum. Will you do this for me?
Yes, I will, Grandpa. I will.
Thank you, granddaughter.
Mary Kate, I heard about your grandfather. I'm so sorry for your loss.
Okay.
What can we do to help?
Well, he's been requesting that we teach him the 4 laws of physics.
I think I know what you're talking about. You see, I'm in physics class.
Same. Me too. What are the 4 concepts?
Conservation of mechanical energy, momentum, impulse, and collisions, maybe?
Cool. So we can do this. We can make his last moment count.
Hey, random kid on the street, come learn some physics! Part 1, Conservation of Mechanical Energy.
This one's for you, Grandpa.
Notice how the random boy does not get further away or closer to Mary Kate. This shows that the amount of mechanical energy is consistent and does not increase or decrease, which means ME initial equals ME final. And you. Conservation of mechanical energy. If a swing moves with an initial mechanical energy of 20 newtons, what's the final mechanical energy? Well, if 20 newtons is the initial mechanical energy and mechanical energy initial equals mechanical energy final, 20 newtons equals mechanical energy final.
Part 2, momentum.
Hang in there, Grandpa.
Watch how the puck changes velocity and direction when random boy hits it. The puck changes momentum, which is a quantity defined as the product of mass and velocity of an object.
A 4,450 kilograms truck has a velocity of 30 meters per second to the north. What is the momentum of the truck? For this problem, you need to find the momentum, and your givens are the mass and velocity. The formula is momentum equals mass times velocity, and you plug in the numbers for mass and velocity. The overall answer is 133,500 kilograms times meter per second to the north.
Part 3, impulse.
Stay with me, Grandpa.
Isla will body bump Mary Kate and cause her momentum to change. Notice when Isla ramps into Mary Kate, how they rise together, and Mary Kate flies backwards with the force.
This is an example of impulse. A 3 kilogram wagon moves west with a velocity of 5 meters per second. It collides with a tree and is brought to rest in 0.02 seconds. Find the force exerted on the wagon when it collides with the tree. First step, you want to write your variables. Then, step 2, draw a free body diagram of the wagon during impact. Step 3, well, find the equation. Then you want to solve the equation. The final answer is 750 newtons to the east.
Part 4, elastic and inelastic collisions.
Perfectly inelastic collision is a collision in which 2 objects stick together after colliding. An elastic collision, on the other hand, is a collision in which total momentum and total kinetic energy are conserved. This is an example of elastic collision. This is our example of elastic collision. A 0.020 kilogram ball moving to the right at 0.328 meters per second makes an elastic head-on collision with a 0.035 kilogram shooter ball moving to the left at 0.215 meters per second. After the collision, the ball moves to the left at 0.400 meters per second. Assume that neither ball rotates before or after the collision, and that both balls are moving on a frictionless surface. What is the velocity of the shooter ball after the collision? First, you would write your givens. Then, you find your unknown, which is the second velocity final, the velocity of your shooter ball. Then you would draw your diagram. Your equation would be m1 times v1 initial plus m2 times v2 initial equals m1 times v1 final plus m2 times v2 final. You would rearrange your equation. That's your equation, rearranged. And then you would just plug it in. Your final simplified equation would be V2 final equals 0.00656 plus negative 0.007525 minus negative 0.008 divided by 0.035. You'd plug all of that in the calculator, and your final velocity of the shooter ball would be 0.201 meters per second. That's elastic collision.
Bye, random kid! Peace out.
Grandpa, you know everything you need to know about the 4 concepts of physics that you needed to know to heal.
Here are the sheets.
Here you go, Grandpa.
My strength is returning. I'm feeling better all of a sudden, and the physics has healed me. Thank you, Granddaughter Mary Kate. I'm alive.
You're welcome, Grandpa.